In this video, we're going to use the node voltage method to find the voltage VO, which is the voltage across this 1K resistor, right? So when we look at this now, we know the first thing we're going to do is identify all of our essential nodes. So we know this is an essential node here. We're going to call this node 1. And we want the voltage at node 1. And we have one more essential node at the bottom here. And because this is at the bottom, I'm just going to take this as our reference node. Okay, so now what we want to do is we want to write a node voltage equation for node 1. So we're going to assume the current is going to flow in this direction here, in this direction, and in this direction. So we're always going to assume the current is leaving the node when writing the node voltage equation. So for the first branch, we're going to have V1 minus this voltage source. And even though it's a voltage source, it's a voltage dependent voltage source. So we have VO over 2 divided by that resistance, which is 1000. Right? Now after that, we have plus V1 divided by 2000, which is the current in this branch here, plus we have, whoa, now look at this. This one's a little different, right? We have the node voltage at node 1, but we have a voltage source with a resistor. And these two are going to be in series. So the current flowing through this particular branch is going to be V1 minus negative 12 over this 1K resistor, 1000. And that equals 0. So even though we have this voltage source here, we're still going to be subtracting this voltage source, right? Now when we simplify this, we know we're going to multiply each of the terms by 2000. So when we do that, we're going to be left with 2. The numerator is going to be V1 minus VO over 2 plus V1 plus 2 V1 plus 12, and all of that equals 0. When we start to simplify this, this is going to give us 2V1 minus VO plus V1 plus 2V1 plus 24 equals 0. When we simplify this further, we're going to be left with 5V1 minus VO equals negative 24. So this is going to be the equation for the node voltage at node 1. Now remember, we have this dependent source here. So we want to write the constraint equation for this dependent source. Well, when we look at this, right, we know that this dependent source is going to depend on the voltage VO. So think of it like this. This is just 1/2 VO. Okay? So we need the voltage VO. Now let's find where VO is in this particular circuit. Will they label VO to be across this 1K resistor here? Now to write the constraint equation for VO, because the positive terminal of this voltage source is connected to this 1K resistor, I'm just going to take the voltage VO to be at a higher potential than the voltage V1, because V1 is connected to the negative terminal. So when I write this constraint equation now, I'm going to write it as constraint equation I'm going to write it as VO minus the voltage at node 1. So VO minus V1 equals this voltage source to be 12 volts. 12. Okay? So that's the constraint equation. I'm going to label this equation 2, but I'm just going to rewrite it so that way V1 can be in front. So we're going to have negative V1 plus VO equals 12. So this is equation 2. Now when we look at this, we have 2 equations and 2 unknowns. So we're just going to use the matrix method. So we're going to have 5v1 minus VO. And then for the second equation, we're going to have negative 1 plus 1 VO. The unknowns is going to be V1 and VO. And that equals negative 24 and 12. Now when we put this in our calculator, we're going to take the inverse of A and multiply it by B. So we know we're going to get V1 equals negative 3 volts. This is the voltage at node 1. And VO equals 9 volts. So that's the voltage across that resistor, right? Now the problem wanted us to find the voltage VO. So because we just found VO when we did the matrix multiplication, we know our answer, therefore it's going to be VO equals 9 volts. So this is going to be our answer for this particular problem, right? So just remember to write the constraint equation for the dependent source, but everything else should be pretty straightforward because we did more than enough examples on the node voltage method already. If you need any more help, leave a question down below and I'll be sure to get back to you as soon as possible.